In this video, we are going to see examples based on even or odd discrete time signals. We know that when you are taking even and odd discrete time signals, the discrete time signal x of n, it is a combination of even part of x of n as well as odd part of x of n. Even values of x of n, it is given by the original signal x of n plus the time reverse version of x of n, that is x of minus n, divided by 2. If you want to find odd values of x of n, which is equal to x of n, the original discrete time signal, minus the time reverse version of x of n, that is x of minus n, divided by 2. In this example, we are going to determine and sketch the odd as well as even parts of the signal x of n. This is signal x of n, which is given from the time period 0 to 3, the amplitude is equal to 1, and from 4 to infinity it is equal to 0. Similarly, the signal from minus 4 to minus 1, the amplitude is equal to minus 1. From minus infinity to minus 5, the amplitude is equal to 0. This is the original signal. For this signal, we are going to determine what is the even component as well as odd component. First, we are going to find the even values of x of n, which is equal to the original signal x of n plus the time reverse version of x of n, that is x of minus n, divided by 2. X of n is given in the question. Now, to find even values of x of n, we have to determine what is x of minus n. So, x of n, x of minus n, it is the time reverse version of x of n. So, here from 0 to 3, the amplitude is 1. So, time reverse version means for the time duration of minus 3 to 0, the amplitude is 1. In the original signal, from minus 4 to minus 1, the amplitude is minus 1. In time reverse version, from 1 to 4, the amplitude is minus 1. That is, 0 value is replaced in the same position. What is there in the time period 1? It is replaced in the time period minus 1. What is there in the time period 2? It is replaced in minus 2. What is there in the time period 3? That is replaced in the time period minus 3. Similarly, what is there in the time period minus 1? It is replaced in 1. What is there in minus 2 time period? That is replaced in second time period. What is there in minus 3 time period? That is replaced in 3. Similarly, what is there in minus 4? It is replaced in the time period 4. Now, next step is we have to add these two signals, x of n as well as x of minus n. So here we are going to add this x of n, this is x of n, this x of minus n. We are going to add these two signals. So when you are adding at time period n equal to 0, here the amplitude is 1. Here also at time n is equal to 0, the amplitude is 1. So 1 plus 1, it will be equal to 2. Similarly, at time period 1, the amplitude is 1 here. Here at time period 1, the amplitude is minus 1. So 1 minus 1 will be equal to 0. Similarly, at time period 2, here the amplitude is 1. Time period 2, the amplitude is minus 1. So 1 minus 1 is equal to 0. Here also at time n is equal to 3, amplitude is 1, here the amplitude is minus 1. So 1 minus 1 is equal to 0. The negative axis at n is equal to minus 1, the amplitude is minus 1. Here at n is equal to minus 1, the amplitude is 1. So minus 1 plus 1 is equal to again 0. Similarly, here also at time period n is equal to minus 2, the amplitude is minus 1. Here the amplitude is 1. So minus 1 plus 1 will be equal to 0. Here also the amplitude is minus 1 for n is equal to minus 3. Here the amplitude is 1 for the time period n is equal to minus 3. So minus 1 plus 1 will be equal to 0. That is, the meaning will be with respect to time period we are going to add the amplitude. Okay, so when we are getting the signal like this. So again, to find the even value, this added value has to be divided by 2. So the amplitude, when you are dividing by 2, this term is changed as 1. The amplitude 2 is changed by amplitude 1, which is actually similar to the impulse sequence. Okay, so even value of x of n, we have to add x of n plus x of minus n. The whole amplitude has to be divided by 2. So what you will get is, you will get the amplitude of 1. Now we are going to determine odd values of x of n, which is equal to x of n minus the time reverse version of x of n, that is x of minus n, divided by 2. To find even values, what we have taken is x of n plus x of minus n by 2. Now for finding odd values of x of n, we are having x of n here, and also we had already determined what is x of minus n. This is x of minus n. Now we are going to subtract x of n minus x of minus n. So at time n is equal to 0, the amplitude here is 1, here the amplitude is 1. So 1 minus 1 is equal to 0. Next, at time n is equal to 1, the amplitude here is 1, here the amplitude is minus 1. So 1 minus of minus 1 will be equal to 2, divided by 2 is equal to 1. Okay. Next, at n is equal to 2 also, here the amplitude is 1, here the amplitude is minus 1. So 1 minus of minus 1 is equal to 2, 2 divided by 2 is equal to 1. Okay. At n equal to 3 also, here the amplitude is 1, here the amplitude is minus 1. So 1 minus of minus 1 is equal to 2, 2 divided by this 2 is equal to 1. Similarly, if you are taking the negative time axis, at n is equal to minus 1, here the amplitude is minus 1, here the amplitude is 1. So minus 1 minus of minus 1 is equal to minus 2, minus 2 divided by 2 is equal to minus 1. Similarly, for n is equal to minus 2 and minus 3. Remaining values, x of n will be equal to 0. So we will get, this is the odd component of x of n. We will see another one example. Here one signal is given x of n. We are going to determine and sketch even and odd parts of this signal. Here the signal is given at n is equal to minus 2, the amplitude is 1, at n is equal to minus 1, the amplitude is 2, at n equal to 0, the amplitude is 3, at n is equal to 7, the amplitude is 1. Remaining values of n, the amplitude is equal to 0. So first we are going to determine even values of x of n, which is equal to x of n plus the time inverse version of x of n, that is x of minus n divided by 2. X of n is given in the question. We are going to determine the time reverse version of x of n, that is x of minus n. At n is equal to 0, the amplitude is 3. So time reverse version, here also at n is equal to 0, the amplitude is 3. Here at n is equal to 7, the amplitude is 1, that is replaced at the position n is equal to minus 7. Here at n is equal to minus 1, the amplitude is 2, that is replaced at n is equal to 1. Here at n is equal to minus 2, the amplitude is 1, that is replaced at n is equal to 2. Remaining values are 0. Now we are going to find the even values of x of n, which is the sum of x of n plus x of minus n divided by 2. This is x of n, this is x of minus n. Now we are going to add the amplitudes with respect to the time period, and we are going to divide that amplitude by 2. n is equal to 0, the amplitude is 3. Here also at n is equal to 0, the amplitude is 3. So 3 plus 3, 6 divided by 2. So 6 divided by 2 is equal to 3. Next we will take it for this location at n is equal to 1. Here it is 0. Here it is 2. So 0 plus 2 is 2. 2 divided by 2 is equal to 1. Next at the next location, here the amplitude is 0. Here the amplitude is 1. So 0 plus 1 is 1. 1 divided by 2 is equal to 1 by 2. Always 0.5. Next here at n equal to 3, 4, 5 and 6. Here also 0. Here also 0. So 0 plus 0 by 2 will be equal to 0 only. Next at n is equal to 7. Here the amplitude is 1. Here the amplitude is 0. So 1 plus 0 by 2 is equal to 1 by 2. Always 0.5. Next we will take it for n is equal to minus 1. For n is equal to minus 1, here the amplitude is 2. Here it is equal to 0. So 2 plus 0 by 2 it is equal to 1. Similarly at n is equal to minus 2, the amplitude is 1 here. Here it is equal to 0. So 1 plus 0, 1. 1 divided by 2 is equal to 1 by 2. That is at n is equal to minus 2. Next from minus 3 to minus 6, both the cases the amplitude is equal to 0. Okay, so 0 plus 0 by 2 will be equal to 0. Next at n is equal to minus 7, here I am having the amplitude of 1. Here the amplitude is equal to 0. So 1 plus 0 is equal to 1 divided by 2 is equal to 1 by 2 actually. Now we are going to determine the odd values of x of n, which is equal to x of n minus x of minus n by 2. We are already determined what is x of minus n from the given discrete time signal x of n. Now we have to subtract this 2 and divide by 2. So at n is equal to 0, here the amplitude is 3. Here at n is equal to 0, the amplitude is 3. So 3 minus 3 by 2 is equal to 0. Okay, at n is equal to 0, the amplitude is 0. Next at n equal to 1, here the amplitude is 0. Here the amplitude is 2. So 0 minus 2 is minus 2 divided by 2. That is minus 1. Next at n is equal to 2, here the amplitude is 0. Here the amplitude is 1. So 0 minus 1 is minus 1 divided by 2. It is equal to minus 1 by 2. Next from 3 to 6, here also 0. Here also the amplitude is 0. So 0 minus 0 will be equal to again 0 here. Next at n is equal to 7. Here the amplitude is 1. Here the amplitude is 0. So 1 minus 0 is equal to 1 divided by 2 is equal to 1 by 2. Similarly in the negative time axis, at n is equal to minus 1, here the amplitude is 2. Here it is 0. So 2 minus 0 is equal to 2. 2 by 2 is equal to 1. Next at n equal to minus 2, the amplitude is 1 here. 1 here it is equal to 0. So 1 minus 0 is equal to 1 divided by 2. So it is 0.5. Next from minus 6 to minus 3. Minus 6 to minus 3. For both the signals the amplitude is equal to 0. So 0 minus 0 will be again equal to 0. Next at n is equal to minus 7. Here I am having 1. Here again it is equal to 0. So 0 minus 1. So it is minus 1 divided by 2. That is minus 0.5. This is the odd part of x of n. Thank you for watching this video.